So I'm using it when I'm enter in. I'm also using it to know where I'm sitting. Maybe I have a lounge access. Maybe even if I'm buying something at a duty free, they need my flight ticket because it has attributes about me. I collected a lot of differences here. I didn't know that I'll get that small screen. So some of the text here will be small. I'll try to repeat them if they are important. But the same differentiation we can find between passport and flight tickets is the differentiation between a very core principle in software security. Authentication and authorization, usually both called auth. When we do authentication, we are doing it once per session. Applications usually has a session for 2 weeks, maybe for a month. When we are doing it, we are using credentials to identify ourselves. And maybe we even have some forms or factors to make this credential more strong, but we are doing it once. Authorization is something that always happens. When we are trying to understand if a user can do something in a system, in an application, we are authorized them. Now, today, the situation is that usually people, or sometimes people are confusing between both terms, or they are doing like authentication that is also authorization. And some other people use authorization in forms of authentication. For example, they are using the multi-factor authentication to give different level of authorization in the application, which is fine, but let's talk about some advanced feature of authentication. So authentication has many advanced features. The main one and the one that everyone is looking for is the credential themselves. So we started with passwords. And then passwords became useless because even the strongest password we can imagine can be cracked really fast. And people actually do not using hard password. They use like the date of birth or something. And then we tried to create multi-level, multi-factors of authentication. So we are using maybe passkeys, maybe authenticator app, maybe SMS authentication. But also for authentication, we usually need user management. We need to manage the user in our application. We need some flows of login, sign up, password recovery, etc. We also need some auditing and reporting, who is logged in now. Maybe we need some feature to do session revocation if something seems suspicious in an account. But developers are usually do not do authentication themselves. The authentication landscape is fully loaded with startups and companies that do everything related to authentication. So for every small feature in authentication, you can create a startup, and then you'll have some users because some reason. For example, Auth0 is really expensive. But so even if you have a startup that say, I'm giving you the same Auth0, but in half price, we'll get user to that. In authorization, on the other way, what usually developers said is, we will do RBAC later. What is RBAC? RBAC is one of the permission models we are using in authorization. RBAC is role-based access control, and we'll get to that later, but same as we'll do RBAC later. But the thing about we will do RBAC later is that developers now are afraid from doing authorization. The reason they are afraid, we'll also get into it. But after some time, they understand that they need something. And then when they come to analyze the last mile of authentication and authorization getting a bit complex than authentication. Because in authentication, at the end, after a user sign in, we only end one factor, the user. Is the user logged in or not logged in? In authorization, we need to get in calculation also the user, but also the actions that the user tried to perform, maybe read something from the database, maybe perform something, and also the resource that they are trying to perform something on it. And when we try to unify the effort, the developers usually get out of their comfort zone, and they decide to start with a very simple thing. They say, OK, we'll add RBAC, we create in the ticket, and then it ends this way. It's getting complex, it's getting across services, and developers feel that something happened wrong. So my name is Gabriel. Sorry for this conference talk opening, because that's supposed to be a talk that I submitted to KubeCon, and I hope it will get there. Today we are going to talk about authorization and how can we solve it from the platform engineering perspective. So As DevOps today, our responsibility is not only of having operations after developer creating the code. Teams are getting to be the platform provider for developers. So the last corporate I worked for, Palo Alto Networks, our platform engineering responsibilities was much more than just operate the containers. We used to bring platforms into the organization. So we even bring a platform for front end into the org. And today we are going to talk about how policy languages could help you to bring authorization as a platform into dev organization. But first, let's talk about the mistake. How could we say developer that they are doing authorization wrong? So this is a very classic starter authorization template. Developers storing the user roles on database, maybe in a data management, and then they are throwing if statements in the code. The problem with this kind of code is that every time the authorization level change, they need to deliver a new code. Deliver new code means new bugs. And in this case of authorization, it became really sensitive because think about, we mentioned that authorization happened in many places of the software workflow, right? We are doing it for API endpoint. We are doing it in the middle of function. We are doing it mostly everywhere. And this if statement is just getting into the code. So what developers usually do, they are putting it in a middleware, in a function that other function pass through when they are calling this function. It's usually happen in API endpoints. So this middleware is wrapping the API endpoint, and they do the authorization calculation there. Now, that's also fine. But as you might notice, RBAC is not the only permission model that we have. The level of granularity we need when we do authorization sometimes requires some more analysis. Sometimes we want to take some attributes from a different place in the system. Sometimes we want to get in calculation the resource attributes. For example, we want to check if a resources belong to somewhere. We want to check if a user geolocation is somewhere. Roles do not provide the granular level that we need for authorization, so then it's getting more and more complex by developers that overloading authorization functions sometimes on top of middleware, but sometimes it's also happened in the code itself. Why? Because when you are coding authorization, well, the example that we showed before was where the scope of the function is not enough. But sometimes we need to get deeper into the function and get decision on it. As authorization you need to get decision everywhere. It's happened that developer creating a lot of authorization spaghetti code into the functions. It happened in many ways. Here is some very common examples that we can see here. We can see it's happened just in the middle of the function. Another point when doing this spaghetti authorization is where you need to differentiate permissions between environments. Sometimes I want to have different environment per different tenants, maybe different environment per different customers, users, or maybe just staging and test environment. And if I want to differentiate the policy, the level of permissions between those environments, I need again to change code to maintain different versions of my code, of the policy code inside our application. That's also happened, and this is a real responsibility of a platform engineering team when developers start to use a different, a new or different frameworks or languages. It usually happens that dev organizations today has like a Node.js layer for the API, and then this Python project for the everything related to data, and then the Golang project for all the deep computation backend services. And then you are getting policy layer that is not unified, right? You want, even especially if the DevOps team is security aware, you want to have one permission model, one policy model for all the applications that running. If we need to code again and again all these if statements, it's getting hard and make the application insecure. Last point about authorization is that it's performant, right? We are running decision making and again. One API function could have 5 decision making. And when we are thinking about performance, we want to make sure that not every developer that creating authorization getting complex decisions that could break the system or something. And also authorization is important for audit. So from all the bad code that we saw here, we try to collaborate a list of best practices for authorization. So first, as we saw, we prefer the authorization or the policy to be declarative. What we saw until now is like imperative style of checking, like if statements that ask some maybe simple, maybe complex question. But what if we can do our policy the way that we are taking decision in a declarative way that everyone can look and understand what happened there. Also, we want it to be generic. We want it to work with every kind of application. If tomorrow some new team decided to work in Node.js, we don't have the problem of telling them, hey, you need to support authorization. Just take the authorization service or the policy service that we have and work with it. We want it to be unified across all the systems. So all the dev teams will have one unified permission model or policy. We want it to be agnostic to the language that we're writing because, again, we want to support different projects. And one of the most important things, we want it to be decoupled from the application code. We don't want the application code to contain the decision making because decision making is something that changes, especially with application. If you think about, let's say, Google Drive, the user themselves defined the permission in the application, right? If I am opening a document, I decide who I'm sharing it with, and then I'm writing like policy rules into somewhere. So I want these rules to be decoupled from the code and defined somewhere else. And we want it to be easy to audit because authorization is something that could lead bugs. We never want like a user access somewhere that they shouldn't get to. So we want to have an authorization service that is really easy to audit and see what happened and why a decision happened. First point when we are trying to get a better authorization service is understand the modeling of permissions. This is the basic building block when we are trying to have authorization in our system. Every authorization request or query started with three principles. User, the principle that trying to do something in the system, action that they are trying to perform, and the resource that they are trying to perform the operation of. And every policy rule can summarized as form of this sentence. Is a user or does a user is allowed to perform some action on a resource. Now, a user or action or resource is not must be a unified term like Gabriel. It could be tons of attributes. It could be data from many systems. And this is where the permission models get into the place. Today in application level security, we are using 4 kinds of permission models. And let's go for each in details. ACL, access control list. If any of you have been in like network engineering 10 or 20 years ago, that was the common permission model that we have. The firewall and switches just hold a huge list of users that were allowed to access some resources. This one is not something that fit for modern application. First, maintaining list is cost. Cost to maintain them, cost in resources, cost in hardware, etc. And also, it doesn't have the level of granularity that we want because for every kind of resource, we need to create a huge list and sometimes differentiate between the list because some other actions. So for every couple or tuple of action and resource, we need to maintain a long list of users. So to solve that, usually what application doing is use role-based access control. In role-based access control, there is not much granularity, but this is really readable permission model. What happened in role-based access control? Each user get 1 or more roles, and then we categorize the users, and then we can define rules together with action and a resource type, or even a resource instance if we want to create a lot of resources and a lot of rules. And then we can write roles that looks like a user with a role admin can create and delete all the resources. And a user with a role editor can only create and edit all the resources, et cetera, et cetera. So we are defining policy rules that are very readable and also very easy to audit, but it has some limitation. The limitation is the level of granularity.
No resource inspection. What does
That's mean, so this is exactly what I'm starting to say. So yeah, so the level of granularity in role-based access control is that we cannot inspect into the list of the resources. Sometimes we want to get in calculation some attributes on the resources. The data that is resource type, for example, document or file, is not enough. We want to get the attributes. We maybe want to get the date it's created. We want to get the organization it's created on. And this is where attribute-based access control getting into the picture. This is probably the most comprehensive permissions model that we can get, because we can create a very complex but simple conditions about our data. So we can, for example, say only a user with attribute of owning a car and has a driving license can drive one of the company cars that are for public use and whatever, right? So we are actually able to create conditions on the users and on the resources that combine many combinations of conditions on attributes. And this gives us a very deep level of granularity for permissions. But ABAC is hard to read and also sometimes hard to maintain, because we need to write somewhere all these conditions. We need to store them somewhere. And also we need to run decision based on it. So we usually want to start with RBAC and then go with to ABAC only in cases we really need the granularity, the inspection into the resources. Another model that is very popular in applications with self-managed permissions, like I mentioned Google Drive or a healthcare company, let's say. So sometimes users owning files or owning resources or has relationship with organizations or relationships with company. If you think about the model of permissions in Google Drive, the roles is not enough because they need the level of granularity of each file or each folder in the system. And attribute-based is also not enough because sometimes the permission is derived by other permissions. So for example, I can maybe create a condition set that said, if Gabriel is part of organization X, they have an access to all files that owned by X. But what if I have a deep level of nesting in the files in the org X, and some of the files down there do not have these attributes? This is where I can take the relationships that exist in the applications, right? Data is usually built by relationship. Even non-relational database has some form of relations between the entities there. So Reback said, let's leverage the relationship that we already had in the software to create permissions based on it. So the permission statements in Reback said two things. First is the basic one, like Gabriel has access to all the files that they add the role to it. So roles in Reback are actually assigned to a specific resource instances, but also we can configure roles that valid for relationship between resources, and then I can derive the role based on other instances. Another point is the ways or the level of authorization we have in the different levels of stack in our application. So first, let's start from the top. We have the user interface. It's probably the graphic user interface, but could be any kind of user interface. But the most important thing there is that we cannot really avoid users from performing something in the user interface, because we are like shipping them the code, and they can, if they really want, they can find some hints for something that we returned from the server. What we want to do is toggle the feature. We want to have the permission that we define somewhere and enforce feature toggling inside the application. So user will be able to see or to do in the front-end application only what they can do. So this is a feature toggling level. In the backend or in the API logic, we want to have the enforcement. So we already saw the code of like this if statement. So we want to replace them by from policy decisions to enforcement points. So instead of like asking if statement if a user can do something, we are just checking if they are allowed of something, and the decision itself is encapsulated. And of course, we'll soon get to it and see how could we encapsulate the decision out of the enforcement point. but it's the most important point. One of the important points that when we enforce stuff in the API level and not in the data level, that we'll get to it soon, is that usually API functions, they are atomic transactions. They are doing multiple things in one atomic transaction. And sometimes we want to have one decision of authorization for all these transactions. So for example, first I want to check that the user can do some billing or something. And sometimes for one API endpoint, I do have many enforcement points that I want to make. Sometimes I want to add functionality in some transactions to some of my users. So this is why the most important enforcement point is in the API, in the, like, let's call it backend to simplify the thing. Then we have the lower level of modern application, which is the data. Of course, could be database, but there are many forms of data today. In data, usually what we don't want to block operations because we want to trust the application, again, because the thing with transactions. But we want the data layer to be able to act to data filtering. So if I call the database, I don't want to return all the resources in the database, but filtered to what the user is allowed to see or read. Also, authorization is not only in the user level, right? So we started today authorization even if in the developer level. So a developer can deploy something or cannot deploy something, to which environment they can deploy or not deploy something. We also use authorization for admission, so like what kind of resources we can create on the cloud, what kind of resources can go live, in what form, what is the size of this resource we want to have, what is the kind of the network we want to have in these resources, etc. We also have system-to-system authorization, right? Microservices are usually authorized themselves to each other to make sure that the service has the right access to the other. And again, the most important part, the end user authorization. The second point is author the policy. And this is where the platform engineering team can bring a service to the developer. If the platform engineering is able to bring the developers some form of authoring policy, then the developer can create the authorization without worry of operating the system. How could we author policy? So as any other software language or programming language, we need to create a contract. What is contract? Is a language. So there are inflation of policy languages lately. We'll talk about only 3 today, but I guess there are at least 10 or maybe 15 at the time that we are talking. Policy languages aims to do exactly what we are trying to achieve. A declarative way to declare policies, and also an engine that can get these policies and answer policy decisions. So policy engine get in one hand the policy, the declarative policy that the developers or someone wrote. In the other end, they get data from the application or the data of the application. And they have an endpoint that the enforcement in the application can query and get an answer if a user allowed or not allowed, but also a filtered data, right? So hence, in the application, the only thing we need to do for the authorization, so our developers are not writing the decision logic themselves. They are not writing the policy logic. This written in a separate place that we can manage the pipelines of it. We can manage the approval flows, the software life cycles of it. And in the application itself, they only need to do the decision. So if, for example, something changed, is not need to change in the application code. So let's start with Open Policy Agent. If you are, and this is where I meant to, sorry about the small text. If you've been in like the Kubernetes landscape, you probably heard about Open Policy Agent in some form. Open Policy Agent is I think the first language that gained real popularity. And I'll not go over the code. I'll show some code samples later. So regarding Open Policy Agent. Open Policy Agent has the widest ecosystem you can imagine. It has plugins for everything. Plugins for applications, plugins for admissions, plugins for databases. If the developer is starting to write, or some admins or security engineers start to write the organization or the application policy in Open Policy Agent Rego language, the policy language of Open Policy is called Rego. it's really easy to plug it into any application. You can get like a policy engine that works with as a Docker container for end application. You can get like a Kubernetes admission controller that you can control the admissions that you create. But also it's complex. It's not easy to write Rigo. We'll get to that later. But it's not that a simple and natural language for developers. So usually, from my experience, DevOps really likes Rigo, and developers hate Rigo. So it's something that needs to be cultural in the organization. Also, one of the main benefits of Open Policy Agent, and this is actually was the, in my opinion, the one that make Open Policy Agent so popular, is the data cache replica. The policy engine Tilder somehow tried to have data from somewhere. Open Policy Agent combines a policy engine and a data cache and a memcache instance. And this is why Open Policy Agent can answer even a very complex policy decision in, let's say, sub 10 milliseconds, which is really fast. You only have to consider the latency of network, but that also can be solvable because the Open Policy Agent, can install together with application or coupled to application. Another language that announced a couple of months ago is AWS Cedar. AWS Cedar came with the trend of having application level authorization using policy as code. And this language designed to be an application level security. It supports only RBAC and ABAC. I didn't mention that, but Open Policy Agent actually supports everything. You can implement any kind of permission model that if tomorrow we'll got a new permission model, it is a programming language. Programming language that can declare like conditional data on it. So it supports any kind of permission model. Cedar supports only RBAC and ABAC because it's designed to be very simple for policy application decision. So in the left-hand side, and again, sorry for it's not that inclusive in the font size. In the left-hand side, we can see like a simple RBAC role declaration that we're declaring that every user with the role admin is allowed to do the relevant actions on the resource from kind task or from type task. And then we can see a bit complex ABAC example, like we are allowing user only if the resources editors attributes has them as the editors of the document, or maybe even more complex ABAC example where we say resource as an owner, and also owner is the principal that trying to access to that, right? So we define relation, but only in one level. We cannot define in more levels than that. So Cedar is very simple for software developers to start. It also already have libraries. It has Cedar Agent, which is something like a sidecar that you can run together with application, but it also has a library for Rust and for Python and for Golang, I think. In my opinion, for platform teams that really want the developers to start work with policy as code for authorization, Cedar is the most easiest way to start, although they don't have that extensive network of ecosystem. The third language that we are going to speak today is OpenFGA. OpenFGA is a result of a paper that Google released called Google Zanzibar. Google has one of the most complex authorization systems that we know in tech. The reason for that, they have many kinds of products, some of them consumer products, like let's say YouTube, some of the enterprise products, some of them are like enterprise consumer products. Like if we think about Google Ads is not the workspace. Google Ads is something that I'm using as an enterprise user, but as a product that not necessarily related to my workspace, right? And my identity in Google could be my personal Gmail, but also my workspace identity. Hence, Google need a really complex relationship declaration between resources and users in their system to get the right level of authorization. So Google Research released a paper called Google Zanzibar that describe implementation of a relationship-based access control system that declared as code. There are many implementations for Google Zanzibar, but I personally like the OpenFGA implementation, We will not talk too much about it because, in my opinion, sometimes Rebug became a topic for a completely different discussion. Most of the applications are really fine with RBAC and ABAC, but OpenFGA is something that lets you declare all the relationships that exist in the application. So for example, if you have a database with some relationship between the tables, you can declare them as policy as code, and then leverage the permissions to write conditions based on those relationships. So again, it's simple for Rebug, but it's really hard to get RBAC and ABAC with OpenFGA. So it's really recommended if organizations really need to leverage relationship for permissions in the applications. The third step is to analyze what we wrote, right? So we are starting to write some policy as code, but we need to make sure that it gets the right decision, even before we are getting to the app. So each engine, as I said, the most comfortable way to work with agents is work with like a container that is running atomically and connected to our data, and then we can query for decision. So this is an example. This is actually an open source that we wrote in Permit. And it's actually wrapping the Cedar agent that's written in Rust, and then you get it as a container that can run as a sidecar with applications. And application can get really fast Cedar decisions on it. But it's not only for production. You can run every policy language as a playground. You can see here an example for Open Policy Agent. Again, sorry for the text. But if we look here in general view, the left-hand side is the policy that we are writing. In the right-hand side, we have the input, which is the context of the specific decision that we want to make based on this policy language, and the data that our application has, because not all the data exists on the context of the policy decision. And then the result, if we are running the policy, usually the result is true or false, allow or not, but sometimes we are writing code that returns filtering of data that we need to use in the application. The fourth point is to enforce the permission. And this is where the developers, again, come and say, OK, so fine, we wrote all these policies code, and we define all the authorization in our application. Now, how do we enforce it in the application? So first, all the policy engine, the modern policy engine, are exposing an HTTP endpoint that you can query with the user action resource and maybe some additional context data, and get the result. This is the most easy way to get like generic authorization, because, for example, also Open Policy Agent and also Cedar Agent as an Helm chart that can plug as a sidecar for every Kubernetes cluster or application. So you just need to configure or declare this sidecar of Policy Engine and then ship it with the application, and then get really fast. For example, in Permit that we are doing authorization, we have an SLA of sub 10 milliseconds per policy decision and sub 2 milliseconds for the latency of the network when it's running as a sidecar. Of course, if you're running it in a different site, it would be expensive. Another point is a library that I personally like called Castle. Castle is a front-end library that allows front-end developer or also some form of Node.js developer to toggle feature based on a set of policy decisions. So if we look here, there is abilities. The concept of abilities in Castle is something that user, as it sounds, able or not to do. And then we can create these abilities like can read, post comment, etc., etc. When we're building the abilities, Castle querying the policy engine with all the data that it has currently and also the data that we have in the cloud. Then Castle getting like an object, and in the code you can toggle the feature based on these policy decisions. This is another point that you can kind of easily plug into policy engine and let also front-end developer to write their own authorization very easy with policy as code. The last point in audit, and this is the great thing about policy as code, all the policy agent has an output with every policy decision that happen in the system. Here we see a screenshot from our cloud service, but probably the JSON that you see here in the right-hand side is just the raw output of Open Policy Agent. So when you are writing policy as code, you can return values, but you can also print values. And then when we are doing audit, we are not getting only the decision. We are getting the query, what happened in the query, the data statements that makes the policy engine get the decision, and the decision that happened. Then developers do not need to write their own audit for each authorization decision. And this is one of the main benefits of using policy as code. Now let's talk a bit about how this service looks like, right? So we maybe decided that we want to bring policy as code. How do we have an atomic authorization system that we can bring the developers to start doing policy as code? So first we have the application. Application is our users, is the policy as code system users. And then we have two planes, the data plane, where the actual decisions happened, and that could be multiple data planes, could be multiple endpoints, because we might want to have different engines for different applications to make it faster, etc. So the data plane is something that is distributed between applications. The control plane is where we are configuring the policy themselves, and it has one instance for many data plane endpoints. The control plane connected into a policy store, which is usually Git repository. It's very easy to manage policy as code is Git. In Git, we mentioned that, for example, we want to have a different policy for different environment. So in this case, for example, we can have like multiple branches with multiple policy configuration for our application. So for example, we having a staging branch and a production branch and a dev branch. And then the developer can very easy make tests in the test branch or the dev branch because they have a policy which is fit for their need for work. And the production policy could be different. The enforcement in the application always stay the same. Only the decision is changing between environment. Also what we are doing in the control plane, so policy decision need data, our data or maybe external data. So in the control plane we are configuring which data the policy engines will need. So we say, for example, we want to fetch data from Azure or from AWS to get more context on the policy decision. Then we are shipping the sidecars or the policy engines together with the application, the data plane that knows how to fetch data from the configuration and also know what is the policy from the control plane. Now the good news is that we have an open source tool that we wrote that does exactly this one. It's called OPAL, Open Policy Administration Layer. It currently supports in Open Policy Agent and CEDAR Agent. And probably when using OPAL, you get everything that we showed before as one or two, sorry. We get what we showed before as one or two containers that you can run together and having a complete policy decision system. So OPAL built from OPAL client and OPAL server. OPAL server is something that runs once, and this is actually the control plane. OPAL server has a concept of something called data fetcher. Data fetcher is like a Python configuration file that you can write. It's already has a lot of fetchers, fetcher for databases, fetcher for, let's say, Salesforce, fetcher for some forms of AWS data lakes, and also has a GitOps controller that know how to pull policy changes from the repository. So if someone changed the policy in the repository, OPAL knows to pull it and push it into all the containers of the data plane that's running. The data plane is wrapping the relevant policy agent. You can configure which kind of policy agent you want to use. Could be CEDAR, could be OPA, and soon could be some more policy agents. And then you deploy it together with your application. So with OPAL, OPAL has actually a really large customer. Tesla is using OPAL, Walmart, NBA. I can drop some big names. Specifically, if we're talking about Tesla, that was one of the earlier adopters of OPAL. Tesla has one repository for all the policy required across end-user application, internal application, developer applications, developer permissions, and admissions. So they are managing all the policy configured in Rigo files at one place, and then using OPAL to propagate it everywhere at the system. Now, I want to show a short demo. The demo will use a combination of Permit Cloud and Opal themselves. But first, let's understand our application and its requirement. Just make sure that I'm on time. OK. So first, we are trying to have, I try to demonstrate an application that has all the permissions model that we talk about. First, let's start with Reebok. We have a healthcare application. Every user should have access to their own medical record and health plan, right? This is the very simple relationship that we want to leverage for permission. Also, every user has a permission to see their members, right? A family or maybe some other member group that want to give them access. But a member is not someone that I saw all their medical records. A member is, I can see only their profile data. So I want to have another role of a caregiver. I want to assign some members a role of a caregiver that allow other members to see all their medical plan data. I also want to have a simple RBAC, a simple role-based access control on the system. So I can show some, for example, if a user has a dental plan, I don't need to be specific for instances. I can have the granularity on the dental plan resource. I don't need to have the granularity of every instance. This is RBAC. And also, I want to do ABAC because I want to allow my users limit the dates that they are giving access for others. So for example, a user can define a caregiver permission for other user, but only for, let's say, 2 weeks. So how do I model the system? First, let's think about the resources that we have in the system. So we have a patient group, which is a resource that defines relationship between users, right? So think about it like a join table in the database that declare in one column the user ID and in other the group that they are belongs to. Also, we have the member themselves, all the profile, the information of the user. We have for each member health plan and medical records. And in health plan, we have a different permissions per the plans that users are assigned to. Then we have also the actions for each resource, right? So now we are in a level of granularity that we are looking only on the resources. In our example, RBAC will be in this resource. So we will have users with the resource to view the alternative medicine in the right-hand side. And later we see how we do Reebok. So here we see 3 kinds of roles that we have in our system. First, as I said, is the system level roles. As we can see here, we have the subscribers, which is for all the user in one level of granularity, all the resource type of alternative medicine. Then we have the role assigned resource. So this is the purple one. So for example, for the patient group, we have a role of member that can do something and a role of admin. Also, for each one, we have an owner role. And also, we have derived roles. What does that mean? So if a user is an admin, is a member of a patient group, that means we want to derive them a member role on a member because we want to show them the profile data of the users that they are belong together with in the patient group. So this is 3 levels of roles that we have in our system: system level, resource level, and derived roles. Then we can define the relationship between the resources. And again, this is something that usually already happened. We just need to drink the data somehow into the policy system. So patient group belongs to, or member belongs to patient group. And also health plan and medical record. Member is a parent of health plan and medical record. It's important to note that in Reebok, usually we don't have a direction in hierarchies. Hierarchies is usually bidirectional. And we can limit the direction in some forms of policy rules. We also have the attribute-based. As I said, if we are assigning caregiver, we want to limit the access only to the condition as we wrote here. So if now, which is the date now, is smaller than the start date or is greater than the end date, we don't want to give the permission. So now that we have our system modeled, we can model it as code. We can model it in some user interface. And then the last one is the relationship that we are defining between instances. So in this example, we'll use a healthcare application of Rick and Morty. RIC has their own instances of member and health plan, and I have a typo here. The health plan and medical record in the left-hand side should be RIC. And also Morty belongs to their own resource instances, right? We took the relationship and the instances that we have in the system and leveraged them to have roles that derived from each resource to the other. So in our example, Morty has RIC as caregiver permission on the member Morty. We will also could derive them a caregiver role on all the Morty resources. Or if, for example, we can see here that Morty is a member of the Smith family, they also have a member to RIC resources. Let's see how it's working real world. So we have here application. This application is like this Galactic Health Corporation. And we have here 2 users that logged in. In the left, we can see RIC, we can see Morty. They are both as a system level role for personal benefit. If I'll take out one of them from this role, so for example, I can go here is specifically on permit, but again, it could happen everywhere in your application. If I will unassign Morty from this role, it will get immediate effect in the system. I don't need to change anything in the database or somewhere. We can see that Morty is not able to access this health plan anymore. Also, we can see that RIC and Morty has their own different profiles. RIC also has a member group called RIC Friends, and he already added Morty into it. So let's try to give Morty permissions to see RIC's data. RIC can go to delegate permission. And because this is Rebug, this is usually where users are assigned permissions to themselves and to their friends. So RIC is actually going, and they can choose what data they want to share. So they will share all the data in his account. And now, the reason we see Morty here, this is a data filtering result, because Morty is a friend of RIC. If we look at the system, we have many users in our system, but RIC is not able to see any of them because they are not member with them. So it chooses Morty, and of course, it derived a role to see all their profile details. But again, they cannot see any other data. And then click Next, Next, and then submit it. At this point, immediately, without any changes, if Morty will refresh the page or just get the policy update with one of the frameworks that we mentioned, is able to see also RIC's profile. Right, so this is the end user application. All the configuration here is happening using code. So I'm going to show only the example of the ABAC code. And here, I'll do it in a light mode. Okay, so here we can see a custom Rego code that declaring attribute-based access control that based on dates. Let's look, for example, this is a bit complex Rego code, but I think I can explain in general terms what happens here. So first, we have the package. Every Rego code can be assigned, belong to package, and then we can import and export those packages so we can extend policies between code that we declared. Also, the Rego has some language functions. And then we have the data. The data, as I said, Open Policy Agent has this data replica. So we can extend the data. We can configure how Open Policy Agent get this data. But here we are defining all the resources of data that our policy decision can get. And the result will be allow. The default value of allow is, of course, false. Now we are starting to declare the policy. The first declaration is this condition. If the policy is not reback, we want to return true. If you remember, this ABAC rule should run only if we are doing a caregiver reback decision, right? So if this is a not reback decision, we don't want to get this policy calculation. The second, we want to filter the resources that are relevant for caregiver, right? This role is actually need to run only if a caregiver is enforced. If a caregiver is enforced, we want to enforce also date boundaries. And then we have, so also we get through here. Now this one, I'll not get into it, but this is some code that filtering the resources that are relevant for the date boundaries. And then we are declaring the date boundaries. This is a function that returns true or false based on the conditions that we declare here. So here is probably a kind of hard example of how to implement ABAC with Open Policy Agent, but it not must to be with the most complex example. So this is in general the demo that I want to see, and I think we can end here and say thank you.
Thank you, Gabriel.
Yeah, stay on time.
Perfect. Any questions? Open for questions, yeah.
So the data plane that you mentioned, when it connects to its sources, is it caching that data, or it is actually doing the lookup right at the time of policy?
So that's really, I mean, it's actually up to you. You are deciding how do you probably caching the data. Opal and also OPA supporting in sharding, so you can shard which portion of data you want per each policy agent. Also, you can decide on the fetching, on the way that you are fetching data. Specifically, Opal works in a eventually consistent algorithm. So if something changed in the policy or in the data, Opal get a notification on it, and then they can delay the policy decision until the data will load. So it will always return a really fast decision, and if data change, they could delay a policy decision for the specific point of time that the data is arrived, and then return the relevant decision for now. So it's probably up to you to decide what data you're putting or caching in each policy agent that you're running based on where it runs. So for example, one application has need for some set of data, but other applications do not need it. So you can configure in the control plane that one policy agent will pull some set of data, and the other policy agent will pull only subset of this data. I didn't mention it, but this one is actually an Opal in GitHub, and there is a very large documentation website on Opal, so you can just read there, or just visit Permit. Permit also has doc. Permit is actually a cloud service that we built on top of Opal. And the main thing that Permit has is a low-code UI to configure policy as code. So instead of writing policy as code, developers can just log into Permit, and they have like a very, it was simple, now it's a bit complex, but like a policy editor that they can edit. So this is the last result of the policy editor. We can see in the left side the resources and the roles per resource. And here we can see the roles, the actions, and here we can see the role. We also can see the role for reback. And if we have ABAC, which I don't have in this table, we also see the condition set. And then they just need to mark here the right permission for the action, and Permit knows how to write this policy and auto-generate it and ship it into a predefined Git repository. And also developers then can also create their own custom rig, etc. But in general, the main benefit of Permit is like a very friendly user interface to configure policy that maybe even product managers can do the policy changes, and the developers has a very comfortable SDK to leverage it in their applications.
The tool also facilitates the development of the policy?
Sorry?
Can the tool also provide ways to deploy the policy as well?
I'm not sure that I understand.
Will it also help you deploy the policy?
Yeah. So actually, what you do in Permit, specifically in the cloud product, so you have the control plane in our cloud as a SaaS. This is the main infrastructure that we are doing. So you have the control plane in our centralized SaaS. You have your own project, environment, tenants, etc. And then you are deploying a PDP, policy decision point, which is a custom container, which is actually Opal client with some more feature that we created. And also you have the permit SDK. So for instead of like writing a lot of sandbox code, the SDK really help you really easily to do everything. If we look, for example, here, so this permit check is actually the call to the policy engine. Okay, permit check getting a user action and a resource. And you can also very easily configure all the policy with APIs instead of writing them. So if you want, this function, for example, is example of assigning user to a member group. So first we check if a user has a permission to assign to their own member group. And then we also use the API, if they have permission, to assign a new user as a member to the member group. So using permit, all the data is probably stays in the application because your data is never getting into Permit Cloud. Only what Permit Cloud has is the configuration. The data itself, the data plane, stay in your network cloud, whatever you want, wherever you run the PDP container.
Anyone else? Any other questions? Any use cases that you see that for what you're doing right now, or maybe within? Yeah.
Yeah, one of my clients has. They have a.
That says a lot, right there.
Yeah, that's the end of my question.
Yeah.
Comment. They have a really. They're financial institutions. They have a lot of complex rules, and right now they're using in-house APIs
Oh,
to process. Does this agent have this permission to do this transaction? Does this user have permission to do this here? And it makes debugging a nightmare. It falls down all the time. And so this looks like a really cool use case. Like it looks like something that would be, brilliant to start applying. How would you go about beginning the process of moving from something homebrew to this?
Yeah, so I can say, I am in permit since January, and we have like 2 segments of users, which is like 90% of our users is either a startup that starting now something, or a company that doesn't have authorization and they want to implement it right. So they maybe use Opal, they maybe use the cloud service. The other 45% is a huge companies, mostly healthcare and insurance, that already has the complex setup and then try to simplify it. And that's actually different. So we have one client that is decided to do a 1-year project to replace everything. We have another client that decided to take one microservice into a Permit Cloud and then started to use that. And also some of them just starting from the open source, right? So they're starting with Opal. They are trying to see how do they leverage Opal or Cedar into their system, and then they are using Opal, and then sometimes they want or need some more support or something, and then they came to us. But the framework is usually, I feel it's like what I say. If they are modeling right, even without thinking about policies, code, or permit, they are modeling even a subset of the permissions that they need, and then they understand how they author us, they can get a better decision in the authoring policies. They can get decision that they want to start with policies code. They can get a decision that they want to start with a cloud service. Whatever it is, now they know what they need to author. And then the other steps are just, as any other software development lifecycle. Yeah.
When you showed the code snippet for AWS Cedar, it looks very much like the IAM policies I'm used to seeing.
Yeah.
Maybe can you help me understand the difference between IAM, AWS Cedar, and maybe IAM anywhere?
Yeah. So the main difference that AWS want to see. So we are like I don't want to call it like early adopters of Cedar. We had access to the code repository 6 months before they released that, and we've been part of the open source release of that. What they are trying to do with Cedar is having the support that YAM do not support for application level authorization. YAM is a set of rules that is very strict, coupled into AWS resources and the admissions of these AWS resources. If you want, for example, to make YAM work for your own identity resource of the users, right? So for example, you're using Okta or you're using whatever authentication provider, it's mostly impossible to do it is YAM, because YAM is really coupled to AWS landscape, to the resources there, to the way that you define. And what AWS come and say, hey, we want the authorization landscape in application getting involved, and we want to also bring language that support application level authorization with 3 generic principles, like a principal, which is the user, action, and a resource. Right, and this is why they released that. They also released a cloud service called AVP, which is like, let's call it open policy agent on the cloud, but for CEDAR or something like that. And in AVP specifically, you can also leverage the AWS setup and data for using CEDAR. So it's kind of, this is more for the admissions and the service-to-service authorization, YAM, and CEDAR is more for application level authorization. This is the main difference.
Kind of follow up on that. Do you know if AWS is going to start letting you write CEDAR policies in AWS environments?
Yes. So what AWS is doing currently? So CEDAR, one of the nice thing that we got from CEDAR policy launch is that they have 3 ways to integrate CEDAR. The first is verified access and verified permissions, which is like an AWS service that let you write policies and store them and run them, and with Permit.io. So the other option is us, which is good for us. We are not direct competitors because the verified access is, if you think about it, is similar to, let's say, like EC2, right? And Permit is more like, let's say, AKS or Amplifier, something like that. So this is the situation in the market. They have their own service, but this is a very infrastructure service. If you want all the UI, the audit logs, the service level, so you're using services like Permit, or maybe other competitor will support that too. Perfect. If any more questions, so in our website we have, I usually put a QR code for it, but if you go to Permit.io, there is a Slack icon. You can just click there and find me, or whatever you want to consider. Anyone else? Thank you.
Yeah, thank you very much. Appreciate it. All right, so that is that. Thanks again, Gabriel, for coming out and talking to us about Permit.io. There we go. Okay, so last thing, or last couple things. Does anybody have any, like, is your company hiring? Anybody out here that's looking for a new thing? Just call that out. There's also, with the recording, we'll be able to kind of put out there if there's any companies that are out hiring that we can kind of push out, let people know. Anyone know anything that they're at their companies? No? Okay. Cool. All right. So DevOps Days KC is the last one we did was in 2019. I believe we did a total of 4 or 5 of them. Who here was at a DevOps Days KC in the past? I think there's, yeah, so a couple of us. We are going to be, we're currently exploring bringing that back. I know I've been kind of talking about that. Who has been to a DevOps Days other than KC? Just a couple of us. Okay, kind of? You were kind of there, or?
I can't remember.
Okay.
Dwayne kind of jumbles it with
Agile, yes. Yeah, that's actually in a couple weeks. Next weekend, actually, if I'm thinking right. Something like that. But anyways, so yeah, so we are in the process of, in fact, the organizing team, we're meeting next week to start kind of looking and seeing what it's going to take to do, bring back DevOps Days KC next year. And that's looking like probably, April kind of time frame. So if you're interested in kind of getting involved with that, that is everything from just volunteering to maybe wanting to, maybe you have a passion for, wrangling volunteers, or you have a passion for, helping figure out speakers, or you have, maybe you've done some event organizing in the past and you want to kind of do it again. Any kind of things that you might be interested, even as simple as like some tech stuff. If you want to, volunteer and stuff,
come see me, and we start to get you kind of in that loop of conversation. It takes a lot to put on a DevOps Days KC. I believe the one back in 2019 was, I believe it was either 300 or 400 people, and it's a good 2 days of single track conference. So it's not you're all in one track, all learning about different technologies, DevOps culture, and a lot of the core practices and principles. So, like I said, if you're interested, come see me, or you can go to I think it's devopskc.slack.com or crap. If you go out to our Meetup page, there's a link for the Slack group that you fill out a quick form, and we'll get you into the Slack group. Find us, start talking, and we're going to start kind of putting all that together so that we can kind of kick that off. So, yeah, like I said, come see me. Again, thank you for coming out. Next month, we're going to be back here, and we're going to have Eric Lee, who is an AWS senior solution architect, who's going to be talking to us about kind of the working on features and how does that, how do you bring that together with the back end? How do you pay attention to the things that matter when from a dev and ops perspective, and going to be demoing a few of AWS's features around that. So that is happening again the last Tuesday of September. We'll be back here. So definitely check that out. That'll be going public on meetup.com probably this evening tomorrow. And tell all your friends and get them here. So any other lasting comments anyone might have, anything they want to, any project you're working on that you want to talk about as well? Nothing? All right, cool. Thank you all, appreciate it. And thank you to Tech Systems. I actually did not, usually we have a quick thing where they tell us about themselves. Do one of you want to come and do a quick thing about Tech Systems? I know you do. Meant to do this at the beginning, but it's a great way to.
We're a mobile IT staffing services company. We work with most major companies here around Kansas City. When you ask if anyone's hiring right now, those are kind of good questions that we have. We work with clients who are hiring. So maybe next time I'll think about that.
Yeah, absolutely. Yeah, okay. Cool. All right, thanks a lot. Again, thank you, Gabriel. Thanks for coming out. And, okay, yep. All right. Thank you all. Have a good night.